Welcome to Rush Learning Hub. In this lesson we will begin our journey through Chapter 1, Chemical Reactions and Equations, from the CBSE Class 10 Science syllabus. Chemical reactions are happening all around us every day, from cooking food and burning fuels to rusting of iron and digestion in our bodies. Understanding these reactions helps us explain many natural and industrial processes. In this chapter, we will learn how chemical reactions occur, how to represent them using chemical equations, how to balance equations according to the law of conservation of mass, and how to identify different types of chemical reactions. We will also explore oxidation and reduction reactions with important NCERT examples. By the end of this lesson, you will have a strong conceptual foundation and be well prepared for examinations. Let's begin our study of chemical reactions and equations. Now, let us understand what a chemical reaction is. A chemical reaction is a process in which one or more substances are converted into new substances with different properties. The original substances are called reactants, and the new substances formed are called products. Chemical reactions take place all around us in our daily lives. For example, when a magnesium ribbon burns, it forms magnesium oxide. When iron is exposed to air and moisture, it rusts. Digestion of food in our body and cooking food in the kitchen are also examples of chemical reactions. There are some common characteristics of chemical reactions. First, a new substance is formed. Second, there may be a change in energy, such as the release or absorption of heat. Third, the physical properties of the substances may change. Finally, the change is usually permanent and cannot be easily reversed. Understanding these characteristics helps us identify when a chemical reaction has occurred. Let's move on to the observable changes that indicate a chemical reaction. Now let's learn how to identify whether a chemical reaction has taken place. Chemical reactions are often accompanied by observable changes. These changes act as indicators that new substances are being formed. The first indicator is a change in state. For example, a solid may melt into a liquid, or a gas may be produced during a reaction. The second indicator is a change in color. When the color of a substance changes during a reaction, it often suggests that a new substance has been formed. The third indicator is the evolution of gas. The appearance of bubbles or the release of a gas is a common sign of a chemical reaction. The fourth indicator is a change in temperature. Some reactions release heat and are called exothermic reactions, while others absorb heat and are called endothermic reactions. The fifth indicator is the formation of a precipitate. A precipitate is an insoluble solid that forms when two solutions react with each other. Let's look at an important NCERT example. When aqueous solutions of lead nitrate and potassium iodide are mixed, a bright yellow precipitate of lead iodide is formed. This yellow solid clearly indicates that a chemical reaction has occurred. Therefore, whenever we observe changes such as color change, gas evolution, temperature change, change in state, or precipitate formation, we can conclude that a chemical reaction has taken place. In the next slide, we will learn how chemical reactions are represented using chemical equations. Now that we know what a chemical reaction is, let's learn how chemists represent reactions using chemical equations. A chemical equation is the symbolic representation of a chemical reaction using chemical formulae and symbols. It provides a simple and standardized way to describe what happens during a reaction. Consider the word equation. Magnesium plus oxygen gives magnesium oxide. This can be written as a chemical equation, magnesium, represented by Mg, reacts with oxygen, represented by O, to form magnesium oxide, represented by MgO. In a chemical equation, the substances present before the reaction are called reactants, while the substances formed after the reaction are called products. The arrow symbol, shown between reactants and products, indicates the direction of the reaction. It tells us that reactants are converted into products. Chemical equations are important because they are simple to write, understood by scientists all over the world, save time and space, and help us understand and balance chemical reactions accurately. As we can see, chemical equations provide a clear picture of what happens during a chemical reaction. In the next slide, we will learn how to balance chemical equations according to the law of conservation of mass. After learning how chemical equations are written, the next important step is balancing them. A balanced chemical equation contains an equal number of atoms of each element on both the reactant side and the product side. Balancing is necessary because of the law of conservation of mass. According to this law, mass can neither be created nor destroyed during a chemical reaction. Therefore, the total mass of reactants must always be equal to the total mass of products. Let's look at an example. Consider the equation. H plus O gives HO. If we count the atoms, we find that hydrogen is balanced, but oxygen is not. There are 2 oxygen atoms on the reactant side and only 1 oxygen atom on the product side. Therefore, the equation is unbalanced. To balance it, we add coefficients before the chemical formulae. The balanced equation becomes 2H plus O gives to HO. Now, both sides contain 4 hydrogen atoms and 2 oxygen atoms. The equation is balanced. Remember an important rule: only coefficients can be changed while balancing an equation. Never change the subscripts within a chemical formula, as that would change the substance itself. The steps for balancing are simple. First, write the correct formulae. Second, count the atoms on both sides. Third, add suitable coefficients. Finally, verify that the number of atoms is equal on both sides. Balanced chemical equations help us accurately represent chemical reactions and are essential for solving numerical and conceptual problems. In the next slide, we will study 2 important types of chemical reactions: combination reactions and decomposition reactions. Now let's study the first 2 major types of chemical reactions: combination reactions and decomposition reactions. A combination reaction occurs when 2 or more substances combine to form a single product. The general form of a combination reaction is A plus B gives A. One common example is the burning of magnesium in oxygen. 2 magnesium atoms react with oxygen to form magnesium oxide. This reaction releases heat and bright white light, making it an exothermic reaction. Now let's look at decomposition reactions. A decomposition reaction is the opposite of a combination reaction. In this type of reaction, a single compound breaks down into 2 or more simpler substances. The general form is A gives A plus B. A common example is the decomposition of calcium carbonate. When calcium carbonate is heated, it breaks down into calcium oxide and carbon dioxide. This reaction requires heat energy and is therefore called a thermal decomposition reaction. Decomposition reactions can also occur due to electricity or light. Depending on the source of energy used, they are classified as thermal, electrolytic, or photolytic decomposition reactions. To summarize, combination reactions form a single product from multiple reactants, while decomposition reactions break a compound into simpler substances. These two reaction types form the foundation for understanding more complex chemical reactions. In the next slide, we will learn about displacement reactions and double displacement reactions. Let's continue our study of chemical reactions by understanding displacement reactions and double displacement reactions. First, let's look at a displacement reaction. A displacement reaction occurs when a more reactive element displaces a less reactive element from its compound. The general form of this reaction is A plus BC gives AC plus B. Consider the example. Zinc reacts with copper sulfate to form zinc sulfate and copper. In this reaction, zinc is more reactive than copper. Therefore, zinc displaces copper from copper sulfate and takes its place. To predict whether a displacement reaction will occur, we use the reactivity series. An element higher in the reactivity series can displace an element that is lower in the series. Now let's study double displacement reactions. In a double displacement reaction, two compounds exchange their ions to form two new compounds. The general form is AB plus CD gives AD plus CB. A common example is the reaction between silver nitrate and sodium chloride. When these solutions are mixed, silver chloride and sodium nitrate are formed. Silver chloride appears as a white precipitate, indicating that a chemical reaction has occurred. Double displacement reactions often result in the formation of a precipitate, a gas, or water. These products help drive the reaction forward. To summarize, in a displacement reaction, one element replaces another element. In a double displacement reaction, ions from two compounds exchange places to form new compounds. Together with combination and decomposition reactions, these reaction types help us understand a wide variety of chemical changes occurring in nature and in the laboratory. In the next slide, we will learn about oxidation, reduction, and redox reactions. Let's study oxidation, reduction, and redox reactions, which are among the most important concepts in chemistry. First, let's understand oxidation. Oxidation is the addition of oxygen, the removal of hydrogen, or the loss of electrons by a substance. For example, when magnesium reacts with oxygen to form magnesium oxide, magnesium gains oxygen. Therefore, magnesium is oxidized. Another example is when hydrogen is removed from a substance during a reaction. This is also considered oxidation. Next, let's understand reduction. Reduction is the addition of hydrogen, the removal of oxygen, or the gain of electrons by a substance. Consider the reaction between copper oxide and hydrogen. Copper oxide reacts with hydrogen to form copper and water. In this reaction, copper oxide loses oxygen and becomes copper. Since oxygen is removed, copper oxide is reduced. Now, let's learn about redox reactions. A redox reaction is a reaction in which oxidation and reduction occur simultaneously. Look at the reaction. Copper oxide plus hydrogen gives copper plus water. Here, copper oxide loses oxygen and is reduced, while hydrogen gains oxygen and is oxidized. Since oxidation and reduction happen at the same time, this is called a redox reaction. Redox reactions are extremely important in everyday life. They occur during respiration, combustion of fuels, photosynthesis, corrosion of metals, and many industrial processes. Let's quickly revise. Oxidation means addition of oxygen, removal of hydrogen, or loss of electrons. Reduction means addition of hydrogen, removal of oxygen, or gain of electrons. And when both processes occur together, the reaction is called a redox reaction. In the next slide, we will explore important NCERT activities and real-life applications of chemical reactions. Chemical reactions are not limited to laboratories, they happen around us every day. Let's explore some important examples from our daily life. First, burning of magnesium ribbon. When magnesium burns in oxygen, it produces magnesium oxide and emits a bright white flame. This is a combination reaction and releases energy in the form of light and heat. Next, rusting of iron. Iron reacts slowly with oxygen and moisture present in the air to form rust. Rusting weakens iron objects and can be prevented by painting, oiling, or galvanization. Now, let's look at digestion of food. In our digestive system, complex food molecules are broken down into simpler substances by enzymes and acids, making nutrients available for absorption. Another important process is respiration. Inside our body cells, glucose reacts with oxygen to release energy needed for all life activities, producing carbon dioxide and water as byproducts. Moving on to combustion of fuels. Fuels such as LPG, petrol, diesel, wood and coal burn in oxygen to produce heat and light energy. This reaction powers vehicles, industries, and cooking activities. Finally, photosynthesis. Green plants use sunlight, carbon dioxide, and water to prepare their food, glucose, and release oxygen into the atmosphere. This process is essential for maintaining life on Earth. These examples clearly show that chemical reactions are a vital part of our everyday life, helping us understand the science behind the world around us. Congratulations! We have successfully completed Chapter 1, Chemical Reactions and Equations. Let's quickly revise the key concepts. A chemical reaction is a process in which one or more substances change to form new substances with different properties. A chemical equation is the symbolic representation of a chemical reaction using chemical formulas and symbols. Balancing equations ensures that the number of atoms of each element remains equal on both sides of the equation, following the law of conservation of mass. In a combination reaction, two or more substances combine to form a single product. In a decomposition reaction, a single compound breaks down into two or more simpler substances. A displacement reaction occurs when a more reactive element replaces a less reactive element from its compound. A double displacement reaction involves the exchange of ions between two compounds, resulting in the formation of new compounds. Finally, oxidation is the addition of oxygen or removal of hydrogen, while reduction is the removal of oxygen or addition of hydrogen. These processes often occur together and are known as redox reactions. Now, let's test our understanding with a few exam-style questions. Question 1. Which of the following is a combination reaction? The correct answer is option B. Calcium oxide plus carbon dioxide forms calcium carbonate. Question 2. What happens when ferrous sulfate is heated strongly? The correct answer is option B. It decomposes to form ferric oxide, sulfur dioxide, and sulfur trioxide. Question 3. The reaction in which ions of two compounds exchange to form new compounds is called. The correct answer is option C. Double displacement reaction. Excellent work! By understanding these concepts and practicing regularly, you'll be well prepared for your CBSE examinations. Thank you for learning with Rush Learning Hub.